Welcome back, everyone. We're going to be solving LeetCode 130, surrounded regions. So we're given an m by n matrix called board, which contains x's and o's. We need to capture all regions which are four-directionally surrounded by an x. And we can call a region captured by flipping all o's into x's in that surrounded region. So this problem is going to be very similar to island count, and I think the problem is count the number of farms in a grid. We solved both on the channel before. If you haven't solved them, go solve those ones first. Essentially what we're going to do is take that underlying concept that we used to solve both of those problems, and we're going to do it here. So we are going to find the number of islands in this grid, and as long as this island is not touching the boundary of the grid, right, either the first column, the last column, or the first row and the last row, then we're going to take that island, the cells in that island, and we are just going to flip them into x's, and that will give us our output result. So we are going to use a breadth first approach to solve this. So let's implement our queue. We'll say from collections import our DQ. We will set that up, and there is not going to be anything on here initially. So we are also going to have a visited set. So we'll say visited is going to be equal to a set, and we will also have an array called islands. What we're going to do is, we're going to find all these islands in the grid. If it is not touching the boundary of the grid, we're going to place that array onto our islands array. And once we're done running breadth first search, we will loop through this islands array and grab every cell in every island in this array and then just flip it to an x. So let's run breadth first. We'll say for row in range length of our board, for column in range length of board 0, we are going to say, okay, if board of our row column, if that is equal to an O, we know we found the start of an island. But we also want to check and make sure that we have not visited this cell before. So we'll say and row column pair not in visited. If this line executes, then we are going to add that row column pair onto our queue. So we'll say queue dot append the row column pair. So like I said, we're going to find every island, and then we're going to place that island onto our islands array. So we're going to have an array in here, so we can grab all the cells with breadth first search if they're an O and place it here. So then after the breadth first finishes running, we're going to take this island array, place it here. Now, in order to determine if we are at a boundary position, we are going to have a variable. We'll call it edge or boundary, whatever you want, but we are going to set it initially to false. So if we ever run into a boundary position in our breadth first approach that we're going to run, we will set this to true, and if this is true, we're not going to take this island and place it here, because that means the island that we're currently at has a cell which is touching the boundary of our grid, which means it is not four-directionally surrounded. So with that said, let's implement this breadth first. We'll say while the length of our queue is not equal to 0, we're going to grab the row column pair with queue dot pop left. We are also going to say visited dot add this row column pair. Now we are going to check, are we at a boundary position? So we'll say if r is in 0 or the length of board, then we're going to set edge equal to true. We'll check the same, but for columns, and this should be board minus 1. So we'll say if c in 0 or the length of board 0 minus 1, then we will set our edge equal to true. Otherwise, we are going to say island dot append the row column pair. Now we need to check, so if we're at the very first cell in our grid, right, 0, 0, we need to check the row below in the same column, the row before in the same column, and then we need to check the column before in the same row and the column after in the same row. So we'll say if our row plus 1, right, so we're here, now we're going to check this cell right here. So if row plus 1 is greater than or equal to 0 and less than the length of our board, and our column is greater than or equal to 0 and less than the length of board 0, and our plus 1 column not in visited, and our board of row plus 1 column is equal to an O. If this line executes, we're going to add that cell onto our queue so we can continue searching. So we'll say queue.append the row column pair. We will also add it onto our visited set, so visited.add the row column pair. Now we need to do this 3 more times, right? We just checked the row below. Let's check the row above where we are currently at. To do that, we'll just take all of these r plus 1s and change them to r minus 1. Like so. Now we will check the next column. So we'll take all these r plus 1s, get rid of them, and swap them out for column plus 1. Column and column, we'll change that to plus 1. And this one should be plus 1 as well. So we'll copy this. Change all of the column plus 1s to column minus 1. Okay, perfect. Now, once we exit this while loop, we've finished running the search on the island. So we need to now check, okay, do we have cells in our island? Meaning, have we found an island? And is the edge equal to true or not? So we'll say if the length of our island is greater than 0 and our edge is not equal to true, meaning we have found a valid island that is 4-directionally surrounded. If this line executes, we want to take this island and place it onto our islands array. So we will say islands.append the current island, and then once we exit all of this, we want to now loop through our islands. Right, we're done running the search on our grid. We have found all of the islands that are 4-directionally surrounded. Now we just need to flip all those cells. So we'll say for island in islands, we're going to grab the cell. So for cell in the current island, we will now say board of cell 0 and cell 1 is now going to be equal to an X. So let's get rid of some spaces and run this because we don't have to return anything. Up here they tell us don't return anything, just modify the board in place. So this is all looking pretty good. It should run, so let's run this. And I misspelt board somewhere. Line 12. Right here. So we'll rerun. Hopefully I don't have any more spelling mistakes. Perfect. We passed both test cases, so we'll submit. Awesome. And it does run. So the time and space complexity for this problem is going to be O of the rows times the columns for both. All right, that'll do it for LeetCode 130.